Welcome to the fourth slide. Still under we're looking at general solution questions. We are looking now at the second category of general solution questions that require co-ratio conversions, equations that require co-ratio conversions. And this is nothing other than something you already know when you talk about cofunction. The cofunction of sine is cos, the cofunction of cos is sine. So when we look at the example, let's look at example 1. Says determine the general solution of cosine 3 alpha is equal to sine alpha. Take note, cosine 3 alpha is equal to sine alpha. The angle here is thrice and the angle here is single. It's also important to take note of that, especially when the angles are not the same, it's not going to be easy for you to solve equations that don't have the same angle. So at one point, you make sure that at the end of the day, you end up with ratios that are the same, angles that are the same, so that you may be able to collect like terms. Now, this question is a little bit different from the questions we have already answered because it's going to need a co-ratio conversion. In addition, the questions we finished to do in the second and the third slide did not have a domain. This one has a domain from negative 90. Theta is ranging between negative 90 and 90, implying that after solving our general solution question, at the end of it all, we need to test for the angles that lie within the range of negative 90 to positive 90. Now, what do we do when we're answering this question? Try to change either the left-hand side or the right-hand side to have the same ratio. If I'm changing the left, it means the left will have the same ratio with the right, or I'm changing the right will have the same ratio with the left. So what do? Let's look at our co-ratio conversions here. Sine alpha can also be written as cosine 90 minus alpha. Cosine alpha can be written as sine 90 minus alpha. They are the same things. Sine 3 alpha is equal to cosine 90 minus 3 alpha. Cosine 3 alpha is equal to sine 90 minus 3 alpha. Now, I'm using one of these ones here, especially I prefer to replace cosine alpha because it usually has a lot of solutions. So instead of avoiding all that confusion of calculations and a lot of things to do, I decide to replace cosine 3 alpha instead and write it in terms of sine, and I can write it as sine 90 minus 3 alpha. You can see that this is exactly what we are actually doing right here. I replaced it with that. Now, having said this, I said equating the angles and begin to write the general solution here. Now that the ratio is sine and sine on both sides, and even here is positive and there also is positive, implying that actually the left-hand side is equal to the right-hand side. So what happens now? Ignore the ratios and equate the angles. Take note of this. The moment you begin to equate the angles, like I did here, that 90 minus 3 alpha is equal to alpha, you also begin immediately to write the general solution. You won't write it in the next step, but this is the step where we need to write the general solution immediately. Remember, sine has a period of 360 degrees, and therefore when you're writing your general solution, multiply by k, multiply by 360. Define always k at the beginning. You can use any other variable you want, k, m, whatever variable you want to use, as long as you define it, it's okay. And if I go back a little bit before we go ahead, now all this one, the easiest way to solve this is to consider that actually both of them are positive, and sine is positive in the first quadrant and in the second quadrant, and it means that's where our general solutions will come from. So what did I say? When the ratios are the same, equate the angles. Just pull out the angles 90 minus 3 alpha, which we have here, and alpha alone, and begin to derive the general solution. That is your first quadrant. That will always be your first quadrant. And then transpose alpha onto the left, it becomes a minus. Transpose 90 onto the right, becomes a minus also, plus k multiplied by 360. Collect the like terms, is negative 4 alpha is equal to minus 90 plus k. When you divide through by negative 4, both on the left and on the right, you end up with alpha equal to 90 by 4 is 22.5 degrees. Positive divided by negative is a negative, and then 360 divided by 4 is 90. K is an element of integers, and that is the first general solution coming from the first quadrant. The second general solution will come from the second quadrant, since all these signs are positive. We also beginning from the same spot. From there, the angles are written is 90 minus 360. However, take note here. Here now, when you're saying, remember, in the second quadrant, we have 180 minus our reference angle. Our reference angle on the right, this sign is alpha, the angle. So it's going to be 180 minus alpha. On the right, we have alpha. If these were two angles, you'd put them in the bracket. But now it's alpha. So how we took it, 180 minus alpha in the second quadrant. Plus k multiplied by 360. K is an element of an integer. Transpose your alpha onto the left-hand side, it becomes a positive. And then transpose the 90 onto the right, it becomes also a negative. So this is minus 3 alpha plus alpha, and this is 180 minus 90 plus k multiplied by 360. I'll define my alpha at the end. Minus 2 alpha 90, k divided through by negative 2 all on the left and the right, and you end up with alpha as being negative 45 degrees minus k multiplied by 180. K is an element of an integer. Now we are done solving the two general solutions. However, if we go back to the question at the beginning, it says that for alpha ranging between negative 90 and 90, implying that we have to test for the angles here now. So when we are testing for the angles, it's easy. We get our calculator, write this general solution as is given to you, 22,5 minus the k. I'll put the k eta, just put two brackets and open another bracket which actually has a 90. And close bracket here. If you don't do that, it will give you an error. It will not be able to give it to you. Now, the k is an integer. Integer could either be positive or negative numbers. So now I'm testing between negative 90 and 90. So what do? When I'm on the general solution here, on my calculator, if you can view it very well, I can begin by placing a 1 here, or even put a 0. When I put a 0 and press equal to, my calculator will give me 45 over 2, which is 22,5, and it's one of the answers here that I do have. And when I go back on the calculator also and scroll and go back and change that 0 and put a 1, I'm now playing around with the integers on the positive side. Put a 1 and press equal to, it will give you negative 135 over 2. Change it to decimal 67,5. 67,5 is one of the solutions. Why? Because it rises between the range of minus 90 to 90. When I continue and go on the calculator and continue and put a 2, the 2 will give me negative 157,5. And if we come to the range, our negative 157,5 is on the left hand side, is out of the range. Therefore, I'll stop there as far as positive values are concerned. Now I'll all go on and test for the negative values. If I put a negative here and put negative 1 into that bracket, I'll end up with 112,5. And if you look at here, in our range, it stops on 90. We don't have 112 is on the right hand side of 90. It means it's outside the range. And we stop there and consider that actually this solution there is, and this solution are one of the solutions of this general solution. When we come to this also, we do the same. We say 45. Let's write another general solution again. We say negative 45 on our calculator minus with a k, put a bracket here, put another bracket, and put 180 as the general solution says. Then begin testing